Welcome back to the second PowerPoint, or I'm sorry, the second video for Unit 12, where we're going to talk about what most books call measures of central tendency, and your old friends mean, mode, and median will make an appearance. Again, I don't think this for most of you is new content, but we'll take a look at the definitions as we track. And again, the important thing for us to consider is what can we tell people about our data without reporting every single data point? So you tend to say, well, most of them were like this. Well, okay, in what context are we going to talk most? Are we going to talk about the average? We're going to talk about the middle, the one that occurs most often. So the important thing for us to move forward is, as a statistics person, we talk about the differences between population and sample. Population represents an entire set of whatever it is that we might be discussing. We might want to find out about people who are men in this country who are over 60. Well, the problem is it's really hard to get insight and information from every man over 60 in the United States. So often you can't get information about the entire population. So we do the best we can and we pick a sample of that population. And the important thing you probably remember from previous discussions here is that we want that sample to be random. Like you wouldn't want only bald-headed white men, right? They're going to have a bias set that maybe isn't true of someone who has a different cultural heritage, who has flowing red locks or maybe flowing gray hair in a ponytail. So when you grab your sample, it's important that anybody in the population has an equally likely chance of being selected as part of the sample. And that's what we mean when we say that sample is random. But it's true that most statistics is done on samples of a population because it's just so impractical, or in most cases, impossible for us to get information from everyone in the population. All right, measures of central tendency. The first one that we'll talk about is mean. My guess is you were introduced to this in like sixth grade. You add up all the data points, you find the sum, and you divide by how many there are. I've chosen to call my mean X bar. All right, so you see my notation over there. Really spiffy, big old summation over on the right-hand side simply means we're going to add up all our X's. All right, I've chosen to call mine X's. There's nothing magical about X. That could really have been any variable. N, as is often the case in statistics, refers to how big is the sample size? How many data points do you have? So if we're averaging, say, 10 scores, N would be 10. If we were averaging 100 IQ numbers, then N would be 100. Some information about the mean. It's affected dramatically by outliers. So if you're going to report something as the average income of people in the United States of America, we got to understand, man, we got people like Jeff Bezos, and we're going to throw his number in there. That's significantly different than most of the people that we know in the greater Chester County area who have maybe a modest income, but certainly nothing near what Bezos would have or what Elon Musk would have. So when we include those numbers into the calculation for mean, they're going to pull the value. They're going to skew the value. So in the picture you see here, we talk about the thing being skewed to the right. The tail tells you where the skew is. So in this case, most of our data is clustered on the left-hand side. We got people there working hard, making $50,000 a year, $60,000 a year. We got Jeff Bezos out there. Hey, today's Prime Day, and he's dragging big cash. But when we put his number in, it is going to definitely have an impact on the mean. So the mean is susceptible to outliers. All right, examples for this particular set. Firster's got two classes. He's got an 8 o'clocker and he's got 11 o'clocker, and we're going to find some means. It will be interesting to figure out whether the people at 8 o'clock are still asleep. Maybe they're wide awake and they haven't been bored to death by 7 other classes today. And we'll find out how their average scores compare. So for the 8 o'clock class, if we're finding the mean, our first challenge is to go ahead and add the data points. I started showing them 97, 85, 88. Then I got tired and I went with the dots. And then I brought the last couple in at 14 and 87. We will be dividing by 12 because we have 12 data points in the 8 o'clock class. So if we do it successfully, a little calculator action, we figure out that the average for that particular group, 78.5. Is it going to be bigger? Is it going to be smaller? I don't know. We might be interested in finding out. Here's the 11 o'clock class. Same idea. Summation of the data points. Again, 12 scores. So we'll divide by 12. and these guys have an average that's a smidge higher, so 80.1. So based on this statistical analysis, maybe they're brighter kids, maybe they're now awake. Hard to say. I wouldn't put a whole lot of credence into what made one higher than the other, but you simply have some examples of calculating mean. Okay, your author talks about weighted mean because sometimes when you look at a data stack, you can say, oh my God, look, there's a whole bunch of the same numbers. And in that case, you can kind of simplify your calculations if you choose to. Obviously, you could still do what we did on those last two examples and not play with weighted mean. But if you wanted to, here's what we could do. All right, we got another look at the 8 o'clock class. Man, we got some groaner scores there. A bunch of 20s, a bunch of 10s, and apparently this was right after Taylor Swift played Philly. So that explains why there were some pretty abysmal scores. But if you're an observant cat, you can say, hey, check it. I saw a bunch of those 10s, and you can count them. We saw 3 of them. And you get that extension at 3 times 10 for 30. And you say, oh my, there's a bunch of 20s as well. All right, yeah, there are. Looks like there are 5 of those. The extension on the right-hand edge is 5 times 20 for 100. Seems like there's some 85s. Yeah, I got 4 of those. 4 times 85, that gets you your right side extension at 340. To calculate your weighted mean now, you're going to add that right side products, and you're going to add the frequencies, and you're going to find that we are going to wind up taking 30 plus 100 plus 340 divided by 3 plus 4 plus 5. And you say, well, dang, I still knew that there were 12 people. I got 470. If you say, well, I wouldn't have needed to do that in that context, you're correct. We could have found the mean, the same process attack that we used on the previous 2 examples. Streamlines it if you like, gives you an option if you will. Okay. Wow. Pretty sad score. Hope Taylor was a good show. Grade point average. I don't know if Immaculata scores theirs this way, but back in the day we did. So you've got some scores here for Jeff Bridges, and you got some A's, you got some B's, you got a C in there in business law. So hopefully you can get that improved. So we're going to calculate his grade point average. It is pretty universal that A's are worth 4. We used to call them quality points back in the day. B's are 3, C's are 2, D's are 1, F's are 0. We're going to go ahead and calculate his GPA, and it is a weighted average kind of thing because you have a credit attached to each value. So here we go. I'm going to bring him in one at a time. So his freshman class, he got 4 credits for that class, and he got an A. So it's 4 credits times 4 quality points. So he's got 16 points kicking in based on freshman comp. Bring him in. So his psych class worth 3 credits. He got a B. B's are worth 3. 3 credits times 3 for a B, and that's 9 total quality points. All right, theology, he got a B. That's also a 3 credit course. So once again, 3 credits, 3 points for a credit, and there's 9. And business law, 3 credits, but he only got a C, so that's 3 times 2. 2 for the C, so he gets 6 quality points for business law. Good news from a man. He rocked an A in business, math for business. And so that's 3 credits times 4 for 12. What we're going to do now is we're going to sum the credits and we're going to sum the quality points. So he's got 16 total credits for 52 quality points when we add 16, 9, 9, 6, and 12. So to calculate his grade point average, we take the quality points, 52, and cut it by 16, the number of credits, and we find out that my man Jeff's GPA for this semester is 3.25. Man, he might have made the dean's list. All right, if we happen to have group data and we want to find an average or a mean, what we tend to do is identify the midpoint of each class, and then we multiply that midpoint times the number of scores we have in that class. We sum all those and we divide. So here's an example for us to look at. All right, so we're going to track scores 90 to 100, 80 to 90, 70 to 80. And honestly, guys and gals, this is the form I usually use with my class structures. And in this context, the low score is included in any class, but the high score is not included in any class. So for those who are familiar with phrases like open and closed as it relates to intervals, okay, you're kind of looking at that here. So from 90 to 100, including 90, but not necessarily including 100. Okay. So if we got frequencies as described, 10 in the first class, 10 in the second class, 8 in the third class, 6 in the fourth, and the last class from 50 to 60, 6 people down there not doing so well. we wanted to find our average, we find the midpoint for each class interval. So in the middle of 90 and 100 is 95. Middle of 80 and 90 is 85. And you can do the arithmetic for those. You multiply the midpoint times the frequencies for the class, and then you do some summations as we did previously. So we'll sum the right side column, we'll sum the frequencies, and we'll be able to calculate our average if all we had was a class interval structure, a frequency table that gave us intervals. So the mean in this case would be 78. Median, you've heard before, it's the part of the highway in the middle of the road. The median is the middle value for your data stack. Significantly important for us to find median, the data must be in order, either ranked from highest to lowest or lowest to highest. Doesn't matter. Personally, I tend to rank mine high to low. Median's the middle, cuts the data in half. 50%'s bigger than it, 50%'s lower than it, 50th percentile. If there are an odd number of data points, the median will actually be one of the data points. If there are an even number of data points, the median is the average or the mean of the two middlemost data points. And again, we got to keeping track that we have to rank them. So example 6, I've taken the liberty of counting how many data points that there are. First of all, we'd have to sort them. So the click just brought in our sorted data stack. And what we would now do is figure out how many data points that we had. And oh my goodness, there are 13. So we would be looking for the middle at data stack of that data stack as data point number 7. And you'll notice that in this context, our median is 82. There are in fact 6 scores above it and 6 scores below it. So it is the middle of our data points. All that's changed on this example is one more person's in the data stack. So we're not going to have an odd number of data points. We'd still have to put them in order. So there's my sorted order from highest to lowest. This time there are 14 data points. So there will not be a true middle in the data stack. We'll look for the 2 scores that are middlemost, and they are the 85 and the 82. And in those contexts, there are 6 above and 6 below. All right, so you would average those to create your median. And the average of 85 and 82 is 83.5. So in the context of an even number of data points, you will be averaging the 2 scores that are in the middle the most to create your median. A little bit on median, it's not as impacted by outlying scores. So if we gave the median, the fact that you got a ridiculous number by Jeff Bezos doesn't have quite the impact that we saw when we considered mean. So outliers are less effective to median than they are to mean. So if there are medians, this just gives you a visual about which one gets pulled more towards that outlier. A mean does, whereas a median's more resistant. Mode is our next and final measure of central tendency. It's the data point that occurs most often. I never really thought this was that meaningful. I guess it could be if you gave a quiz and everybody got 9 out of 10 and somehow somebody got a 5, then maybe the mode describes the data really well. But for me, this one's always been kind of if there is nothing that is more often occurring than others, we don't have a mode. It's also possible to have more than one mode. So, all right, in the visual here, it looks like there were 2 modes, one that's a relatively low number and one that's a relatively high number. Again, if you want to impress your friends, this is bimodal 2 modes. Quick example, there's a data stack that represents the number of people in families. Family size for some folks in that 8 o'clock class. Looks like the number that's most prevalent probably looks to be 3. And I'll be goodness, that is the mode of this data stack. 3 occurred more often than any of the other data points. So that's mode, and that wraps our 3 measures of central tendency. We'll be back soon with video 3. See you then.